Huge welcome everybody to Eigen TV. Today we've got an exciting topic for you and we'll be talking about the future of digital twin. Dave Hodgson and Andrew Delugar have joined us from KBR. And if you actually go back on our YouTube channel, you'll be able to see that we did an entire digital twin series with these two lovely gentlemen. So please do go back and watch that. And of course, if you've got any comments whatsoever, pop them below and we will get back to you as quickly as we can. So a huge welcome. Thank you so much for joining us.
So do you think it's actually possible to have a digital twin of an entire country?
Good question.
It's possible to have a limited digital twin, and it'll grow.
I mean, I can see layers that would build up a complete country of digital twin, but I see it perhaps more in themes you've mentioned about the geospatial and the geographical. I've got in my mind, probably because we're in the heart of the energy transition, a digital twin literally about the energy use and the generation and the supply, all about getting to this low carbon. I could see something around that.
And a digital twin of the gas pipeline network on the map that has the pressure ratings of all the pipe work that makes up the network, so that when we do manage the transition from pushing methane and other hydrocarbons up and down this pipeline, we can then easily subvert that network to becoming a hydrogen transmission network. It will have different requirements of it because the pressures and the leak rate and all that kind of thing from hydrogen will be different from hydrocarbons, but fundamentally we're going to need a digital twin of it, and then we can simulate the behavior of that pipeline in this new regime.
So I guess two questions based on that. And then one is the access to that information is sensitive, possibly.
Yes.
So this isn't a digital twin that I can just access. Then this is a level 5 security clearance or whatever.
Well, you can access the mappy bit, but you can't access the pressure in the pipeline bit.
Okay, so there's a layer of like current info or design info even of it.
Yes.
But then so that what if analysis, say you want to do a simulation. Now I've got an interesting scenario where I want to run some future states. I want to do it offline because I don't want to impact the current thing. So I need to take a copy of that, twin into some sandboxing environment. But then I need to run another system. And so going back to the digital twin is lots of different systems. How would that look? What would be the chain of systems that would come together to give you your answer? Because just to clarify that question, when we talk about you ask the digital twin, it's like the computer HAL in 2001, where there's this single interface. You just ask it a question, and it somehow knows what to do. So the question we're trying to answer here are what is the ability of the current gas distribution network to handle hydrogen? But the complexities of that are immense. And you also, is the model even up to date with the current state of all the pipework? And I mean, there'd need to be some survey, but just what would the technology stack look like to answer that question?
Ever growing. I would say that if anyone made a list of all the possible use cases for a digital twin, let's just keep it down to a process plant rather than the entire pipeline network of Britain on a map. We would probably, somebody could easily add another one perfectly validly. So I think one of the things we need to do is saying, for this period, this is our list of potential use cases. We maybe go for a few of them, and then we take stock, and then we say, well, what other use cases have cropped up in the intervening months? What should we add? What should we drop off our current list of use cases? So it's ever evolving. And I've been starting to say that actually the digital twin is probably a little bit like Teams or it's the core of a whole lot of satellite applications and use cases will feed off it. And some of them might use, like analogy of the digital twin, or say analogy of the phone, your GPS locator and your clock. Some of them might use your history of calls. Some of them might use a combination of all three. Some of them might use your photos. multitude of different things, but all together eventually working off the common standards that is this phony thing and the software behind it to enhance our lives.
So what you're saying then is that the digital twin holds certain facts.
Yes.
And then if I wanted to do my flow simulation model, I actually use a flow simulation application that I plug on top. So like the lens that I look at the data goes through this special function that has all the knowledge about how to understand pressure drop in pipes and fluid behavior. That's not built into the digital twin. Or rather the data model. So what I should say is you're saying that that application forms part of the digital twin, but to use it, you need to go up to that application and ask your question. There isn't a single interface that I type my question into that then goes, this looks like a flow assurance problem. I need my flow assurance module, and then it goes and sorts it out for you. Actually, it's certainly for the, I mean, maybe that would happen one day, but we're thinking in the short term. Yeah, and natural language processing.
Yeah, you probably need an intelligent human being who knows his or her way around the digital twin and understands the potential and what needs to be done to get the sort of questions you're asking first. And eventually, if there's some clever AI machine sitting next to that knowledgeable individual or knowledgeable group of individuals, it will eventually learn the questions that the knowledgeable individual is capable of answering now, thus releasing the knowledgeable individual to go sailing at the weekends or to do a better job. This is one layer on top of what he or she is doing now.
So there's a path to evolution to get to that single portal.
Yes.
Where you say you get your initial function sorted and working with the data, then you can automate the next layer, which is deciding which function to use.
Yes, and likewise, the standards are important again, because we need to know, or at least an understanding of what the standards are. You and I would look at a drawing and say, oh, that's in inches or that's in millimeters. We would quickly switch our units of measure standard. We need to teach a machine to understand to understand the standard for the standard, so it knows what sort of units to use in particular.
You stretched my sort of thinking of digital twin there, David. I always see it but as a shop window where you can get a view on everything, but the actual processing and the manufacturing or whatever the product is actually being generated elsewhere, and it's just a window on the top of those tools. So I see it a bit more like that.
To a certain extent, you're right, but let's take the 3D model. The digital twin during a project life is the part complete model still in the factory.
Yeah.
Likewise, the high simulation, likewise, the engineering data. It's the best shot we've got at the data at any given moment in the life of the facility. And this goes back to one attribute is how trustworthy is this item of information, which goes back to maturity management, because you can say, well, look at all the mature stuff that's trustworthy and offer up the untrustworthy stuff to make the untrustworthy stuff more trustworthy.